So at the beginning of the semester, we talked about a concept, we called it overloading. Remember that? So we said that if, for example, I have some kind of a function that displays the sum of two things. So I have int display sum, int f, and int s, and it adds the two things and returns it and displays it. Good with that? Very simple thing, right? So if I have a few integers over here, I can call that display sum thingy, saying display sum, and I'll put over here a and b, right? Three years later, right? Are we okay with this? Very cheesy thing, right? And then we said, what if I have series of doubles in here? And if I want to actually work with doubles, not with integers. So if I actually do the display sum again for the doubles, and I put over here x and actually z, x and y, and showed over here the z, it will run because the compiler casts those things. It gives me a few warnings, say double possible loss of data. But what it gives me is not a precise thing. It's casting everything to a double, right? So the remedy for that would be to overload the function. We learned that at the beginning of the semester that one of the features of C++ is that the signature of a function is not the name of the function, but also its arguments. So when I create a display sum with that double schmubble thingy over there, and I put the exact same logic, now if I run the program again, the proper function will be called, and I'm going to have actually 30.3 over there. So each function is called based on its signature. Are we good with this? Are we okay with this? Okay? Right? That's function overloading. We could expand that thing to have even classes. So I have over here displayable class, displayable class. It's a container, and container. So as you see, this is an interface that you just created. Okay? So that's, I hope you didn't forget to put the default constructor in it. Well, anyways, so that's the interface, and it's overloading with something. Then a container is a displayable that is doing that, and a mark is a displayable that is so on and so forth, right? So we created kind of an inheritance between a container that is a displayable and a mark that is a displayable. So they're both displayable objects, and they're both implementing the display. And also, they happen to implement operator plus, both of them. So if that's the case, I can actually use the exact same methodology, which is essentially having something like this. So I'm going to actually bring a mark and a container in my main. OK, so I have an instance of a container, that 100, and D 200, and E. So it's exactly like integer, but it's mark in a container. I can overload the functions that I had with the exact same logic, but for display sum, for the container, and the mark. So as you see, these four functions are identical. The only thing that is different over here is what? The types, right? So if I run the program now and I actually display all the sums, well, for the containers and all the good stuff that I have. So if I actually write something like this and make it a bit more fancy. Now, all the displays are called perfectly for the function for the class that they are designed for. Are we okay with this? That's boring. The damn thing is the exact same thing. Like, take a look at this. Like, why am I going to write this thing over and over? If I have a 7-year-old sister, you can actually tell your 7-year-old sister to write this for you over and over. How? You simply tell to your sister, okay, I'm going to write over here type. So I'm going to actually, you get one of these. Okay? And you change that int to type, right? Type, 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 type. Or you don't have to write type. You can write over here, right? And you give it to anyone. Say, change that to long. What we're going to have? Long, display sum, long, if long. As long as the plus works for both of them, it's fine, right? It doesn't make any difference. You can give it to any person and tell them just replace those things with a type and you're fine, right? So essentially, you don't have to write the code again. We can do that with a compiler. All you need to do is to say, hey, this is a template, and the type name is home. Done. And you don't need these 4 things anymore. What happens? You created a template, literally template, English language template. What is a template? You know, template that you draw. So you create a template. You tell, hey, if anybody is using display sum, look at the types that they are using and generate the function for me. So when in here you are saying, C display sum A and B. What is the type of A? Int. Int, int. It simply says, oh, the type is int. I'll replace everything with int. Now you have one that is with E and C and D, and these are, what is the E and C and D? Containers. It says container display, container this, container that, and creates it for you. Okay? That's it. And that makes your life much easier for 2 reasons. First, you don't have to code as much. When you have a specific logic that matches many different types, instead of rewriting the thing over and over and copy and pasting, you simply write the template and you just see what types are important in here. And then you do that one. Okay, so whatever type that is involved. Maybe you have a loop over there with an integer that counts. That is not your type. That is some mechanism that works inside your function. You don't change that. But the types that are playing a role in your function and you want those things to change, that's what you do. Easy breezy. Okay? And templates are very useful for 2 reasons. Number 1, you don't write much code. Let's make your life easier. Number 2, if you don't call any display sum function, you're not going to have any display sum function created for you. Your executable becomes small. A library that you create in your utils, the library that you create in your utils, and you have lots of functions in there that you reuse. When you add that one to your program, it gets compiled, right? When it gets compiled, the binary code is translated and is inside your executable. Use it or not. It's like you're carrying a toolbox that's like 50 kilos, and you just want that tweezer from it. But you're bringing it in just in case. Wouldn't it be nice that you didn't carry anything with you, and if you wished, it would just materialize for you? That's what templates are. You create the logic for it. The compiler looks, is it needed? If it is, it generates it for you. Okay? And that's what we call a template, function templates. And it matches for anything. Anything that you have done with any function that you rewrote the function 2-3 times with the exact same logic, you can just see which types you changed You make those types the type name of your template, and you're done. If you, by the way, if you look at the older versions of C++, that type name is changed, is used to be written like this. It works the exact same way, no difference. You see? Works the exact same way. The reason that they put type name over there was like people freaked out. Oh, class, oh my God, was that a class? No, it's just type name, okay? So write type name to be happy, and just makes more sense, okay? We're okay down to this point? There's one catch, and you need to remember this. It's extremely important. For the compiler to be able to, generate the code for you, it needs the entire code. You cannot modularize a template. You cannot have the header files in .h and the body in .cpp and only include the header file and think that the compiler can actually compile it. Remember about the compilation that we had at the beginning of semester? I told you how it compiles. At each time, it only compiles one module. And when it's compiling, it only sees the header file, not the CPP file of the neighboring file. Correct? So when it compiles, it only sees the prototype. It doesn't know what the logic is. So another thing that you need to know, and you need to remember this for the rest of your life, template modules, they only have one file, and it's a header file. They don't have a CPP file. Everything must be in the header file. Your prototypes, your logic, everything must be in a .h, because all of it is needed for the compiler to be able to generate the code for you at compile time. And this is called creating the code at compile time, which means the logic exists, the compiler compiles. If it's needed, the functions will be created for you. If not, it won't. Number two, if you overload a template, there is no problem. You can do it. You can overload a template with no problem, which means if you have seriously? If you have something like this, that you overloaded the template, your overloads always supersede the template. So the template only is in play when the function doesn't exist. When the compiler sees, oh, the function is already there, so why should I create it? But if you call it for an integer, the compiler says, I have a display sum for Mark, but not for the integer, so I'll generate it for you. So remember, overloading supersedes templates. If you have an overload, the templates won't get created. All right? You good with this? Right? Are we okay? But it's not good very much. Like when you think about that, you're like, I don't want that. Why do you do that? Why do you need to actually overload something? When the logic is different. When I want the display sum to work over here, but let's say for a mark, I don't want to write sum over here. I'm going to say total mark. So the logic inside this is different with that one. So I cannot repeat it. Okay? That's the only time that you overload. And we have something that we can use, and it's called template specialization, which means if the prototype is the same, but the logic is different, you can still make this one a template to save space in your code. Because maybe you don't have a mark and you don't want to carry the executable, the logic for it in your program when you're not actually displaying a mark. So you can actually make this a template. We'll call it a specialization for a function, for a specialization for a function template. And the specialization, I'll show you what the format is, will tell to the compiler, For everything, do it like this. If it was mark, do it like that. Okay? So how that works? Let me just... So what you do, if you want this to be a template too, you write over here template. You don't put anything in a type name, which means this is a template, but it's not for all types. It is only for the mark type. And to tell to the compiler what is this thing for, you write over here a mark. So now you're telling to the compiler, this is for all display sums, but if the type is mark, select this one. Yes? For every scope needs a template beforehand. So, for example, in future, you'll see we can actually have class templates. If you create a template for a class, remember we created an array of integers? You can make that array of anything. Because the logic is the same, right? We can make that a template so it becomes array of anything. We can do that. So if that's the case, and you have a class that is a template, and the methods are templates too, right? Obviously. If you put the methods outside, for each method, you have to have a template at the top. So each template's power is only for the scope that is coming after. If you have a second and third, each one needs a template. So at any time you see an empty template like that, it means this is a specialization for an already existing template, and which means the display sum works down. Pretty good? Yes? What's the difference? When you say, why do we? The reason is that you're giving extra credit to operator overload. Operator overload is a function. Change display sum to operator plus. It becomes the operator. Who cares? Operator overload is just a name. It's a function. Thank you. That's what we call documentation for a template. Which means when you are creating a template like this, you add a documentation at the top saying this template works only for classes who support plus operator overload. If I'm using over here some class that doesn't know what is operator plus, the template's going to fail for it, obviously. Obviously. So you have to have documentation for template that this logic only works. Now, if I want to go in detail with this, this logic only works for types that can be copied because it's passed by value. If the copy constructor is deleted, this is not going to work for it. So copy constructor is needed, okay? Plus operator is needed. It has to be insertable into OStream. So all these things must be documented. That the type of this template must be copyable, must support plus, binary plus, must be insertable into OStream. And then this template will work for it. You have to have all the features of this available in that class, and then that class will work with it. It usually works the other way. You don't make a class work with a template. You write the template who can work with a family of classes. You know what I mean? The other way is a bad thing to do. Don't change the design of your classes so it can fit with a template. That's not a good thing to do, okay? If you are writing the template. But if you are using a systems template, then that's a different story. Now, you see all this that I have written over here now. One thing that is important that you can force the compiler to use a specific template if you want to, which means if for some reason I want this display sum that is using for doubles to be used for integers, I can actually force this to create the integer one. So by adding an int in front of display sum, I'm going to say, I don't care if you have two doubles in here. Use this with the integer version. And I can actually change the other one to double. I don't care that A, B, and C are integer. Use the double version. Now if I run it, you'll see that the double is called as an integer, and the integer is called as double. So you can actually change it to whatever you want. Okay? Of course, this is only needed when you have cases that there is confusion. Let's say what if I want to do something like this? You don't do it for stuff like this. What you do is when you have a case that is a little unusual. For example, you have X and B in here, which means, take a look. Now I'm saying create display sum, and I put a double over here and an integer over here. There is no match for this because these two bytes must be the same, right? So the compiler is getting confused. Now you're saying, OK, it's an integer. This is an integer. I want this to be treated as an integer too. So you can resolve this conflict by stepping in and telling to the compiler, I know this is confusing. Just use the integer version for me, and then everything's going to be fine. If this x is convertible to an integer, of course, then it will work, which is it will be casted. OK? So specialization and so on and so forth. And that was the introduction to templates. OK? And that's what we need to know about the templates in OOP244 with a touch of classes that I'll talk about later. So actually, I'm going to talk about the classes and stuff the next day you're coming. So the next day you're coming, I'm going to repeat all these. I just wanted your mind to get ready. And please go study templates. Go through the template lecture, the notes over there, and study it. Come back over here. Then I'm going to tell you everything about templates right up to OOP345. And as a matter of fact, you can then use actually the standard template libraries of C++. Makes your life beautiful. Yeah, that's it. Questions? Suggestions? Objections? I had 2 students who had problem with the quiz. OK. Yours is I have to check yours. Yeah. Yeah, so I have to check yours. Do you have class after this? OK, so you can just sit at the corner while I have 3, 4, 5 class, and you can do it over here. I'll set it up for you. OK? And I'll check yours to see if it's OK or not. So that was the introduction for the templates. You have 2 quizzes up, quiz 4 and quiz 5. I wrote you what you need to study. Study those things hard. Because I literally bring statements out of those texts, and I take a word out, and I'm going to say fill it back in. OK? The questions are not traversable. You cannot go back and forth in it. You have one question, you answer that, you go to the next one. You cannot go back to it. And you have to install Respondus, which essentially locks your computer, so you can actually do it. And that's that. I gave you lots of extra time. They're like for example, quiz 5, we have 6 fill-in-the-blanks questions and 2 walkthroughs. And you have 30 minutes for it. So each question is going to take you, what, 1 minute? That's 6 minutes over there. And then you have lots of time for the walkthrough. OK? Yeah. So do those things. And those are very important studying for those quizzes. Specifically, I put it this way. It makes you ready for final test.